My name's Tom Harold. I'm an artist from Indiana. I build kinetic metal sculpture. Specifically, I build what's called rolling ball sculpture, also called ball runs or marble runs, marble machines, Rube Goldberg sculpture. Today we're going to specifically address rolling ball sculpture built out of steel. I wanted to make this video because I see a lot of repeat questions on the web, specifically on the comes up every so often on the Yahoo email group that Eddie Bose has set up for rolling ball sculpture, and there will be people who were, like myself, wanted to get started working with steel, bought a welder, came home, and then went, okay, now what? There are not any videos, at least not as that I know of as of the taping of this video, that deal with the basics of putting welding small steel rod together, which is what you're going to end up making a whole lot of your track out of, or at least that's how I make a lot of my track. So we'll be TIG welding. I'll be using stainless steel, but the same techniques apply for plain steel. I'll make mention if there's any differences that you're going to want to look out for, but by and large you can consider that most of it's pretty much the same. We'll be looking at the butt weld, which is the ends of two rods coming up together, because eventually, you know, if you make something long enough, you're going to run out and need to add more to it. I'm sure you probably don't want to sit here and watch me talk about it forever, so let's fire up the welder and get down to it. Alright, this is what you're going to use a million times over anytime you got to join pieces of track end to end. Pretty common if you build a rolling ball sculpture of any length, you're going to run out of rods sooner or later and need to add more to it. On this one here, this is, as I mentioned before, we're working with stainless rod here. I've got a couple of pieces cut, and you can see I cut them with a pair of bolt cutters, and it leaves that pointed, you know, kind of a dual bevel here. Actually, you can see right on this says 308L, which is real common grade of stainless. The L stands for low carbon, but you'll find this stuff. It's nothing special as far as stainless goes. It's not like some, you know, like surgical grade or anything like that. But you can see how we've just barely got 2 points meeting up there, and there's really not much. For one thing, where it narrows right there at the tip, when you hit that with a torch, that's going to try and melt off and crawl back towards the rest of the larger end of the rod. The heat's going to go to the thinnest place first. We'll concentrate there. That is going to heat up the most and try and melt away first. So, and those 2 points are going to try and like I said, crawl away from each other, and you'll end up with a, you know, gap. Although I'm going to try and weld it. We'll see if I can fake it and make it. What you're going to want to see instead to have a really nice setup that looks like this. Check that out. Super sweet. Those two ends button right up against each other. Another thing about having the two pieces joined together is the weld becomes becomes I guess tolerance, not the word, but it responds really well to low heat. You don't need to put as much heat together or heat to it, because you've got the two pieces joined together so closely. They will also feed heat into each other. And this also reminds me of doing soldering work, where you need to heat both pieces, both work pieces, equally, so that the solder would flow from one to the other. If you've ever done anything like that, well, welding's basically the same way too. If you don't get your pieces heated, having a joint that fits up tight like this makes your life a whole lot easier. So it's going to get dark here, and we're going to put some heat on these and see what we can do. Here we've made our weld. We actually succeeded in fusing a couple of pieces of metal together. You could see in the process there, like I described there, you know, the middle part tried to melt away because those are the thin areas, and we didn't have good contact. So this is what we've ended up with here. The heat got through pretty well, and you know, it's, I mean, for what it's worth, it is a weld. Is this something that you want in your sculpture? Kind of doubt it. So this just illustrates one of the reasons why you're going to want to have a decent prepared surface to get a decent weld going on. So we'll dispense with this sort of foolishness and do a proper weld here, and show you how this is all going to go together, and what a really nice one can look like for you. All right, we have our surfaces prepped here, and you can see they're nice and square. They're not perfect, but they're pretty close, at least certainly close enough for us to get a decent joint here. I also wanted to take a minute here. You can see this is what the tungsten looks like on mine. It's kind of broadened out a little bit here because I've used it it's usually sharper when I start, but you can get an idea of how it's ground down. You'll want to get a dedicated grinder for your tungsten. If you don't, you'll get little medical particles in there off of whatever other materials you're using on your grinder. It'll get stuck in your tungsten and dirty up your tungsten, and then that'll screw up your weld. It'll mess up your arc and just make life a lot less pleasant for you. I'm using a 1/16 inch tungsten, thoriated. I think there's lanthanated and serrated also that you can use. I haven't tried the other ones. I've heard that they really don't make that much of a difference. But thoriated is what my welding shop has, so that's what I use. And you'll also, I'm welding with my my argon pressure at 12 psi. That works great for just about anything that we're going to be addressing. Any more gas than that doesn't give you any better weld. It just means that you run out of your gas a whole lot faster, and that stuff costs money. So if you can keep the gas pressure low, you're dollars ahead in the long run. Yeah, I'm using argon, nothing fancy. I'm not using any kind of a helium mix in there or anything like that. That's kind of for specialized, exotic metals applications or special circumstances that we're not going to be dealing with. There are some other electrode sizes, 3/32, and there's a 40 thousandths. 40 thousandths is pretty tiny. 3/32 is larger. You probably won't need those for this. I think if you do, you kind of figure it out that that the tungsten you're using is too big or too small. So, all right, we're going to darken things down here and put this weld together. Okay, so you'll see there that that went pretty quick compared to the last one. I had to kind of wait around for the joint to kind of take on that. This one we got a better deal out of the whole thing, and you can see I didn't get all the way around the rod there, just the way it's positioned. I'm not able to, but it looks pretty nice. It's nice and smooth there. If I was going to do something like, and this is just fusion, I didn't use any fill rod, obviously. You didn't see me add anything in there. You could just flip it over and do the other side there too, and it would come out real nice. I'll hit that real quick here, and we can see what it looks like when it's completed. Alright, so here we are. Got the whole thing finished up here. Turned out pretty good looking there. If I was really putting a piece of track together, I'd make sure the rods were better aligned. You can see there I got them out of alignment a little bit. But the weld's looking good. Color looks pretty decent on that. Didn't take me too long to put that together. You can see that when you've got things the pieces mated up, it really flows together pretty nicely. So we'll clean this, and you can get an even better idea of how it looks when you're done. So here's our weld all cleaned up. It's looking pretty good there. We don't have any holes in there. This is just a fusion weld, so you will see some low spots in there. I've never found it was anything that ever really hurt the performance of the sculpture. At least if if it wasn't too noticeable. I suppose if it really got down to it, I would just add a little bit of fill in there, just a touch. Doesn't take very much at all to fill it in. And actually, I will do that here in just a second and show you how. I'll just fill it, since it's kind of got a double elbow right there. I'll just add one of those and kind of smooth one of those over. But you can see it looks pretty nice. Didn't even have to add anything to it. I'm going to take this low spot that's right here on the top, that area right there. And this is the rod that I'm going to be using to fill it with too. This is 40 thousandths stainless fill rod, standard stuff for in the welding shop, nothing fancy. I'm also going to block up my work here before I get started. I recommend that, not because this piece is especially wobbly or anything, but because I am often the one who ends up running into something and shoving something out of the way, moving something out of position right as I'm all set to weld. Positioning is something you'll also want to remember. It's pretty important. You'll want to make sure you have your arms rested kind of up near your wrist somewhere. Anytime you get any farther than that, you'll really it'll be hard for you to keep the torch, keep it from wobbling. And when you've got that, you want to keep a pretty close distance between your workpiece and your tungsten there. So let's see. You can see in the video before, but I'll show here with the light on. Something like this is kind of where, and you can see I don't have my hand position. You can see I'm kind of wobbling when I'm really positioned. Even something like this, I've gotten a better position there, and I'm not getting so much wiggle. If I have to, I've even used two hands. I've grabbed the torch up near the up at the head, kind of on the back cap there, and use that to steady things and position them. Anything to keep from, you don't want to take this thing and touch it down on there. Anytime you do that, it stops your arc, and lots of times you get your tungsten stuck in the workpiece, and then you also get contaminants on the end of your tungsten, and you'll have to break that off and resharpen it, and take your hood off and everything, and it's really just a big hassle. It just slows you down. So positioning's really important, and I've actually found that when I've made a lot of mistakes, it was because I was forced to be in a situation where I could not position my rest my arm comfortably, and ended up dipping the tungsten into the weld pool. So make sure that whatever you got to do, just make the effort to get yourself positioned comfortably so that you can make a decent weld without too much monkeying around. So, alrighty, we'll drop the hood and put the heat on this thing and get ourselves a little fill rod here. Now, there we go on that. You can see where there used to be a divot there. It's actually, I brought that up, and I just gave it a little tap there with the fill rod, and you can see the spot that I filled in there. So if you've got a little hole to fill like that, that's what you can do. I know maybe that looked like it was just a piece of cake, but I've been doing this for a while, and I remember I had to do a lot before I could add just a touch in something like that. But keep working at it, and it won't take you it won't take you as long as you think, I suppose I should say, before you can do some work like that. Might help a lot for you to grab some plate, maybe some 1/8 inch steel plate, and just make long weld beads, and just make long strings, straight lines. I did a lot of those when I first started. I bought a bunch of steel plate and took two pieces and butt welded them together, and I just did a whole bunch of those until I wasn't sticking tungsten in the weld all the time, and that sort of thing, and then you get really good at making little spot welds. So there we go. We've got that all cleaned up, and looking pretty good and fairly level surface there. Certainly a very solid joint that will last for years to come on a piece of rolling ball sculpture track. Just wanted to give you a quick view here. There's our nice little bit of filler on there. You can see along the bottom edge right there, where I've added that right in there. There's the drop. So, and it's kind of filled out. It used to be a kind of a little divot like that, and well, I've moved the divot around here a little bit, but I give you an idea of at least how you can add a little fill to something when you've got a low spot. Alright, so there you go, a couple of techniques for building steel rolling ball sculpture. I hope it was of some help. It's the sort of thing that I was looking for when I first started out doing this, and I hope it gives you a little bit of a leg up in the learning curve there so that you have a little more fun and a little less frustration. Again, my name's Tom Harold, and you can check my art out here on YouTube on this channel if you want to click subscribe. I always upload new sculpture work when it's completed, and I might do some more of these instructional videos if there's demand for that. You can check out my website at tomharold.com. I also have a Facebook page, Tom Harold Art, and on my website I blog about art on there as well. So if you've got any other questions or comments, please let me know. Until then, practice, 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 and have fun making some art.